is all of this. Anytime you have these shapes that don't fit one particular formula, you look to see, can you create it by combining shapes that we have formulas for? So in this particular case, to find the total area, it's going to be the area of that triangle plus the area of the semicircle, right? So if you look at the area formulas for each of these, a triangle is 1/2 base times height. A semicircle is 1/2 times pi r squared. Okay? If we look at any of these pieces, do we know any given information already? For the triangle, what is the base? Any right triangle, use the legs as your base and height. So 3 is the base. The corresponding height is 3 also. So there's our triangular region. We've taken care of that portion of it. Now we're going to add the semicircle. Well, in order to find the area of the semicircle, we do need to know its radius. Okay. In order to find this radius, can we solve for this whole side length? Okay. As I walked around and noticed, a lot of you are using trig ratios for this, okay, which is fine. You can still use that because you know that these are 45-degree angles. However, we have another even more efficient way to approach these, and that is a special 45-45-90 triangle has a pattern of x, x, x root, what? 2, right? So if the sides are 3, the hypotenuse is going to be 3 root 2. So that's the whole diameter. Cut that in half. So 3 root 2 over 2 gives you your values. And then again, depending on whether they ask you for exact or approximate value, I think in this case probably approximate, you can plug this into your calculator and come up with your solution. Hey, Molly? So you could also do like 3 squared plus 3 squared equals x squared? Yeah. So if you use Pythagorean theorem, again, it's the same as doing trig. It still does work, but if you know the pattern, again, the pattern being x, x, x root 2, makes it a little bit simpler. They always do try to look for 30, 60, 90 or 45, 45, 90 triangles and apply the pattern. It can save you some time. Any other